Okay, so let's move on to what is edge computing. Now, this is based on a New Stack article called Are Your Apps Truly Nomadic by a chap called Derek Collison. This was published in March. So yeah, very recent. I have no idea who Derek Collison is. I didn't really bother looking up. I just thought I'll kind of, face value, look at what the report was. Paul, where do we start on this one?
Well, again, this is one of the things as an analyst, you're always taught, or as a historian, you're always taught, look at where the person who's writing it is coming from, what's their angle. And this, Derek Collison has developed a platform called NATS, Nats.io. So he's trying to generate, if you like, almost like a niche market that he can drop his application into. So there's a little bit of him trying to create a storyline that I think was quite difficult for him to create, or I don't think he necessarily went about it the right way. He was talking about these nomadic apps, and you and I had a discussion about, does he mean nomadic in the sense that, if you put a sensor or you've got a computer in a car and the car's moving, therefore it's nomadic? Or was it nomadic in the terms that he was trying to describe, which was this sort of absolute commonality from edge to cloud? And he was going far out, to oil rigs and so he had this sort of view that, and you and I think both thought that he was trying to talk about total portability from the edge device to the cloud. And I think you and I both agree that that's, whether it's feasible or not, whether that's desirable is another matter.
So I don't think it was the first description, although that's quite a funny one. I didn't even consider that, to be honest. Actually moving stuff, stuff that moves like cars and whatever. Although how would you move a factory? So that wouldn't work.
No, it doesn't. But then a lot of the article had those sort of conflicts in it that you think, oh, it's this, and then you go, no, it can't.
It's not that. Yeah. Okay, so NAS, just in case anybody's kind of wondering, NAS stands for Neural Autonomic Transport System. Make of that what you will. You can check it out at nats.io. It's partly an open source project maintained by Synadia Communications, and it's on an Apache license 2.0. So there you go. Now, I think there's, it's kind of trying to do the, write once, run anywhere sort of, Java kind of thing, but maybe with a kind of sprinkling of PaaS kind of thrown in, because you could kind of, you can have sort of message queuing systems and, and various other things that ecosystem, the NATS ecosystem kind of throws into it, I presume. So I have to say, I've not kind of looked into all of the details of that, but it was quite interesting to see that.
Its fundamental design and fundamental concept is a replacement for existing messaging systems, on the basis that he felt that, the way in which the existing messaging systems worked were difficult to integrate, scale, all the sort of questions. And he really was trying to get to grips with that. Great, fine. But he sort of then turned it into, at its core, it's like Spark, it's like, MQTT, it's like any messaging traffic, but it seems to be, it's open source, it seems to be scalable, it seems to be integrate with a whole load of stuff. But he's trying to build a platform on top of that, which allows you to develop applications, but also to manage data. And there was less info on that. So God knows what where the direction of travel is for that. So it is, you're right, it's more like a PaaS at the moment, on which you can develop stuff. But I think the sort of concept that it got was that you have this sort of single portable app or application right through the stack.
Yeah.
And it was based on the premise too, that, which I don't think is necessarily correct. He was sort of slightly unclear, but almost that virtually all the data you collect will go back to the center.
Yeah, and I think the issues that I had was I don't think there's a reason why you have certain platforms or certain solutions for certain platforms. So like in the cloud, you got various things that you do there and APIs and stuff like that. For IoT, it's kind of a very minimal sort of thing because you're constrained, your resources are constrained, and the device itself is small on resources, processing, memory, IO, and things like that. So I don't. I think this has been attempted before several times, where you can kind of you start with something very core, and you go, okay, oh yeah, that works on my Raspberry Pi or my IoT device. Great, okay, or it works on a some kind of production factory system or something like that. It kind of starts as very small sort of microcode or something that you can make. Something kind of that becomes your core, and you kind of write your app maybe around that. But then as the application in terms of where you're applying it, not the app as in the program, but the application of where you're putting it kind of goes somewhere else. So it goes to a hospital, it goes to a school, it goes to a ship, it goes to a tank, in the battlefield or whatever, or it goes into a plane or goes to a car. The emphasis of what you need, that core sort of module to do for you, will start changing because there's different demands, either from the infrastructure that is going to run on, so the hardware or device or something, or the communication, or the nature of the actual program that's running on it, streaming and so on, and event driven, etc., etc. So I think there is no way to do that unless the thing is dynamic and says, oh, I'm now running in a tank, so I don't need these modules. I'll only install these modules. Oh, now I'm on a plane, so I don't need those modules that were in a tank. I need these modules, and so on. So I think it's very difficult to try and tick all the boxes, with just one solution, one PaaS platform that does it all for you. Even if the actual service that you want from it is the same one, is a streaming service, or it's a queuing service, or it's a security service or whatever, because even security is kind of different depending on where you are and what you're doing and what the platforms that you're running on, what the program of the app needs from you, as well as a kind of a PaaS module, if you like.
Yeah, I don't disagree. When you looked, I sort of dug into the Nats website a bit more just to try and understand what's going on. And the core of what they were doing was that communications one you were talking about. What happens when you've got poor communications. Now, I'm not technically competent to tell me whether he's cracked that issue, but it's certainly where they were aiming at. But they were also, aiming at, one of the challenges in the environment is all the different sources of data, getting that data back in a format and in a cleansed state so that the central systems can do something with it, but doing that virtually on the fly, and this is, his data management thing. And I couldn't, in the short time I was looking at it, get any real sense of how he did that. There are companies out there who have, data management companies who spent a long time trying to provide, data cleansing and data deduplication and all those sort of issues, and get it as near real time as possible. But it's very difficult to do it right out at the edge. So, okay. Because you've got so many different types of format, we haven't even mentioned the operational technology or industrial IoT with all their different formats. Now, again, working with partners, they seem to have cracked some of that. A German company called iFlow looked like, very much focused on the manufacturing sort of, seems to have helped them crack that. But generally, I just felt he was trying to create his own market space. Although I shared with you the canonical stuff and their micro Kubernetes, what they call microcates, which, we talk about because the articles seem to suggest you could run it anywhere from the edge to the central cloud database. And the answer is yes, you probably can, but why would you? And why would you need to? And would it be the right thing?
Exactly.
And so that's the issue, not so much
Yeah.
can you make it portable across the lot? Yes, and you look at what Canonical's done, you can almost certainly make that portable right across
Yes. Yes.
the piece. But why would you?
Yeah. Is it the
Yeah,
right thing to do?
it's
Is
the
it the
right
right
thing to do.
solution? Because if you're actually in the public cloud, if you're going to now, you've taken the the design of whatever you're doing from the from the edge all the way into the public cloud. In the public cloud, I would want to use one of the XKS
Yeah,
services. So I'd use an EKS,
yeah,
GKE,
yeah.
AKS, whatever it is, because
And the truth,
that's what's geared for
yeah.
that type of environment.
And as long as the APIs and the information, the data coming across can come across seamlessly,
Yeah,
why would you use the little thing that you were using out on the edge
exactly.
in a cloud environment? It didn't
Exactly.
make sense.
Yeah,
And then
exactly. And
he was trying to push
yeah,
that.
and it's not, I mean, you don't even have to go that far. You don't have to even get for that kind of edge thing. I mean, I would argue things like OpenShift has got its place where you can run it, but that doesn't mean you can run it you're not going to try and put that into an IoT device just
Yeah.
because OpenShift has got all these wonderful things in it. You can go, oh, can I put that on the edge? Maybe. I don't know. You might need an actual like proper PC to do that. One of those kind of mini, whatever, ruggedized PCs to do it.
Yeah, yeah.
Whereas actually, maybe if you'd looked at, this solution, for example, the NAS solution, maybe we could have done the same thing using an IoT device. It was much smaller, cheaper, easier to manage and so on. So I think it's horses for courses, and I think that's the problem that I mainly see. Like I said, you're kind of trying to address everything or every environment with that. And then the other point that I kind of, fundamentally disagreed with was the definition of edge computing. It just seemed to be kind of, shaped, in accordance with what needed to be said. And I don't think it's that kind of malleable in that way. I don't think you kind of, shape it that easily, because when you pragmatically come to actually do it, you're back to, what does my stack look like? What does my software stack look like? And again, that same question comes up. Why am I running or trying to run, NATs in a public cloud? That doesn't make sense. Or the opposite of that, trying to run OpenShift on an IoT device. It's the horses for courses again when you come to actually looking at the design and the architecture of what you're doing. And that's why I think, certain pieces of software that have been written or platforms that have been written, for or solutions, for particular platforms are designed for those platforms. They're aimed with that platform in mind, largely. You can you take them and put them somewhere else? Maybe. But is that kind of, as you said, is that the best thing to do?
Yeah.
Yeah.
And I think, I mean, edge has been so widely used as a term, and probably wrongly, from you and I have had the discussion, and I push back a little bit in the sense that a lot of what you and I have talked about has been this sort of software stack, and there's only so far down out to the edge you can take that stack. And yeah, regional data centers, yes, you could probably take it down to a large factory and put the stack out there. But the minute you get out to an oil rig, would you do it out there? No, you would. Would you put it in a car? No, you flipping well wouldn't.
Yeah, exactly. So
well, edge computing has been so sort of used as a term that I don't know. We need to find some other way of describing. But he was. I just felt he was conflicted on a number of times when he was trying to get his story across. And I'll dig out the blog that was on the site that I actually thought came at it from a completely different direction, which was, what's the problem you're trying to solve? And the article really wasn't about what's the problem you're trying to solve. He was trying to make the case for his particular nomenclature, his particular view of the world. And actually, there was a blog on the NATS site that came at it the other way around and gave some examples of the code you wrote to deal with it. Now, I couldn't understand the code to save my life, but the actual issue they were trying to solve is the classic issues that you get out from the edge in terms of data integrity, not duplication of messages going out and all those sort of things that where you've got multiple devices, and multiple steps and hops. Seemed to be that they were addressing those issues, which I thought was quite useful, but he's taken it too much far
Yeah,
forward.
yeah. And I mean, it says that the article's exploring the concept of nomadic applications, software system design operates seamlessly across diverse environments, including cloud, on-premises, and edge computing platforms. So I think that immediately, like I said, I fundamentally disagree with that, because it clashes with that, as I said, that kind of, the horses for courses. You need these things when you're in a public cloud, but you don't need them when you're running them in an IoT device, and vice versa. The IoT, a PaaS that's kind of designed for IoT, let's say, will be fundamentally missing a whole bunch of stuff if you try and run that in a public cloud. You try and drop it into AWS or something. Sure, can it run? Well, yeah, we can make a lot of things run, but are they actually any useful? Are they going to do what we want? And are they going to have the longevity as we progress and innovate what we're doing with that particular project? Is this thing going to scale with us? Is it able to cope with our future demands? Not just, oh yeah, it can do all of these things, tick a box, it works. That's not enough, I think, for the type of agility that we want these days from our platforms and applications.
No, I agree. I think that's absolutely right. And I think, what we've got to get to is, have we got the ability for seamless transfer of information between the end user device and wherever you want to send it, and what you want to do with it. So, I mean, APIs, we've got to have better, standard APIs. We've got to have that transparency of what's happening out there, which is very different from portability.
Yeah, absolutely. Yeah. So, I mean, so the thing I maybe kind of wanted to circle back to was, what is edge? So, I think you and I have had this conversation before. So, so we could, for me, it's relatively simple in terms of I look at it always kind of from the platform that's potentially going to run the app or run the service for us, on the edge. So IoT devices in general would be definitely part of that kind of edge family. So they run certain applications, they do a certain job, regardless of what the software stack is on top of them, they're doing something, right? And then they feed back that information to another potentially edge device, which might be just a general edge computing, device. So that's the kind of the next layer for me, or the next sort of part of that edge definition is just an edge computer. It's just a desktop machine. It's one of those ruggedized things. It's a server.
It's quite often a gateway for all the sensing devices before.
Exactly.
And again, I suppose being less of a computer person as opposed, I started my life out in what I would call edge locations in physical transportation. So I have when anybody talks edge, I'm thinking edge back to the center. I'm thinking of vehicles on the go, those may be, exactly, or factories or maybe, and so there's a physical definition, and I accept, because you've beaten me up over it, that there's a software stack that needs to be taken into account.
Yes.
It's fun, but of course the two are misconstrued. I think we almost need to describe them differently. That sort of software element and the physical. Where is the edge? Well, the edge is all over the place.
Yeah. So the edge and location wise can be anywhere, any of those types of.
But I think I'll shoot somebody if they start calling regional data centers near edge location.
Oh dear, yes, that's kind of splitting hairs, isn't it?
Oh,
so IoT definitely, and edge computing, which is kind of running. I don't care what it's running really, whether it's running Windows servers, running Linux or whatever, is doing a particular job. It might have a local database, might have an in-house developed app, a off-the-shelf app, whatever it is. It's connected to those IoT devices. It's not connected to those IoT devices. That's fine. It's just edge computing. You're just doing something at the edge. You could even argue that hyperconverged infrastructure and how we saw satellite buildings and offices in contrast with the HQ office, with the head office being part of that kind of edge, if you like. But that's not really important. Again, that would be splitting hairs. But definitely edge computing. So IoT and edge computing. Now, I would like to add a third to that, which is edge cloud, because edge cloud is bringing what you were able to do in a public cloud or in your data center to that edge location. So those same apps and services and PaaS and whatever else you want to use that you had and you're used to using and you are implementing right now in your public cloud, you're bringing that to the edge. And as we said, the edge we define as that location, whatever that location is, car, tank, ship, building, etc.
I think as long as the edge location infrastructure can handle that software.
Yeah, exactly.
That's effectively what you say, and
exactly.
And that's the case. That's okay.
Yeah.
But otherwise it don't work.
No.
And the challenge, again, about scaling that up. If you're scaling that up on the edge, it's nigh on impossible to do.
So
in pure cloud terms. So again, what you and I have slightly argued about, can you have an edge cloud? And I will say, actually, in classic terms of what a cloud is, the answer is no. But I do understand the development of that software stack further and further out towards the edge.
So I mean, it's really the same stuff that you'd be running in your data center, because the public cloud providers, the hyperscalers, have not cottoned on to doing like dedicated edge cloud solutions. What they've done is, or what we can do is, we can take whatever they put in whatever they've given us to run in our own data center, which is a stretching of their public cloud services, essentially. So things like Outposts, AWS Outposts, Anthos from Google, and Azure Stack, and things like that from Microsoft. We can take that solution and put that into an edge environment, that kind of physical location definition that we said. So that would make that platform that you're running, that machine or several machines, whatever it is, that cluster, putting that out there, that would make it the edge cloud, because you're essentially now defining the edge by the location, right? And then that would run those same services that you're running, run your Anthos, run your Outposts and whatever, as you were running it in your data center. So that's no different, really. At some point, the hyperscalers might go, I think this is a new market for us. We should strip down Anthos. We should strip down the Azure Stack, and we should strip down Outposts and so on, and actually make it even smaller, and actually put that into the edge and call that the proper edge cloud.
But it is no longer a cloud, and this is where you and I part company, because it is a server, an edge server, using all the tools you would normally use in a public cloud environment.
Yeah, but it's still connected back to the cloud, right? It's still connected back to the public cloud.
Yes, but probably not so much in what I call online real-time mode, unless absolutely necessary. So one of the challenges that nobody's getting to grips with is, with all the IoT devices out there, how much is sense and respond locally? How much do you do locally?
Yeah, the majority would be. In that case, in that case, it would be. But what I'm saying is that the underlying solution, the platform, is the one that we were running in our data center. In our data center, it was a lot more chatty to the public cloud. But now, because it's on the edge, the application that we're putting on top of it to run on the edge is less chatty, because it's designed to talk to that IoT in a bunch of devices, do all the processing for them, or the majority of them locally, and maybe just drop some metadata back to HQ.
It's using the great tools that exist that have made public cloud what it is, and using them locally. Does that make it a classic cloud? I don't think it does, but I mean, we're splitting hairs now. So I think what's happening there, by defining the edge
and that's not U2's guitarist, the edge, by the way. It's not to confuse that, dear audience. But just defining that sort of edge area where we want some computing. We've defined it as IoT. Okay, so we know that's clear. An edge computing, just kind of a standard computer that kind of, as we said, runs the one app or database or whatever, and does that local thing. And then the edge cloud, as we said, kind of, bringing those cloud services out to the edge. So I think how we can categorize that or define that, explain those things, is by saying it's down to the use case. So the IoT use case is very clear. We need some computing, readers, measurement, temperature, whatever, blah, 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 on that tank, on that ship, in that factory, whatever. That's your IoT. Edge computing, we need something that will collect that information, most likely a proprietary application that in-house developed, that will collect the information from the IT, does the processing, does whatever it needs, all done on the edge or mostly done on the edge, and maybe, as we said, send back some metadata. Right. So that's the use case for edge computing. Edge cloud, same thing. But all we're doing there is we're taking the current, kind of the stretched cloud capability to run your, public cloud local in your own data center type of concept that the hyperscalers have given us. All we're doing is we're taking that and putting that capability, those services, out on the edge. And by the fact that that is running the same software stack, and whatever we're doing in that software stack could well be very similar to the edge computing that we described prior. By doing that, the use case changes for that cloud, for that kind of stretch cloud, by putting it at the edge. So that kind of, for me, makes it an edge cloud solution because you're using those services.
I'm not sure I understand the use case per se. I understand what you're describing.
Yeah.
What's the use case?
The use case is describing what the use case is trying to do. Is describing essentially how you're using that platform, not the application use case, because we said we don't really care necessarily what that is. It's, like I said, it's talking to some IoT devices. It's collecting data from the IoT devices. It's processing that data locally. That's fine. That's very similar to what the edge computing was doing. However, we're doing it as a cloud, as an edge cloud, because we want to use the same platform and the services and the infrastructure and the APIs and everything that we're used to using when we do that as a stretched cloud in our data center. When we talk from our data center, from, let's say, outposts or something, AWS outposts, when we talk from AWS outposts in our data center back to AWS, the big the proper AWS. So all we've done is we've taken that outpost and put it on the edge, changed obviously the application, because the application now is an edge application, not that data center application, and not a public cloud application. It's a completely different application, but the underlying platform is still the same. So we can build that application for the edge using the same tools, the same API, the same containers, the same cloud environment, the same automation tools, same security, and so on. So it's all, the same look and feel wherever you are, but it's now physically sitting on what would be in your organization defined as your edge environment.
Okay. All right. Yeah.
So that's how I would see the difference now between just an edge computer, that's talking to those IoT devices, versus an edge cloud that's also, or is essentially doing the same thing as an, talking to those IoT devices. It's just the edge computing is, potentially written or has a software stack that might be different to your data, because you're not going to run like VMware there, right? You're going to potentially run Windows Server, maybe Linux, or something, or a small runtime of Kubernetes, or something like that. But it's kind of Kubernetes on bare metal, right? It's not like in a cloud environment.
I get it. I understand. interestingly, from my
We need a chart. We need to do like a chart
yeah,
for this.
but interesting from my point of view, you're talking about. I'm going to use the term cloud only. I might be over, but a cloud only environment in an organization, in that you are everything you're doing is going back and actually the centralized processing, if we can call it that,
Mhm.
is all AWS based or public cloud based.
No,
Whether
no,
it's
no, not necessarily. No, like I said, the edge cloud is doing exactly the same thing as an edge computing
I get
device.
that. I get that. But in your architecture for the enterprise architecture that you've
Yeah,
got,
yeah.
you are effectively saying that for that set of applications, from the edge to the cloud is
Mhm.
all AWS.
Yes, yes. So the platform, the
Yeah.
underlying platform, the
Yeah.
undergirding platform is all
Yeah,
AWS.
it's all
Right?
AWS.
What you do with it is up to you.
Yeah.
How
That
you want to run it, what the app is going to be. Oh, that one is for edge type of stuff. Great. This one's
so
in my
the
data center.
question
Great.
so
That's fine.
the
That's all
question
different.
is the question is then going to be if my architecture is actually a hybrid architecture and I've got some non-AWS cloud or
Kind of
non-public
a
cloud,
multi hybrid architecture. There you go.
multi-hybrid,
So new term.
whatever the terminology is. But
Multi hybrid. Yeah.
if I've got some of that going on, does that mean I need another edge gateway device in my edge location, wherever that is, whether it's a factory or whatever, i.e., that communicates with the IoT. So that's, I think, all I'm saying. I mean, because I was getting this sort of sense that, if you go down the route of let's say outposts,
Mm.
what you will, or a stripped down version of outposts, all the
Yeah.
way to the edge, you're ending up being front to back AWS.
Yes.
From an architectural point of view, you're saying, well, I'd better make everything AWS. It's an interesting strategy. Maybe AWS ought to be getting a head around it. But, from my perspective, with a much messier world out there, is at what point do you bring AWS into the equation if you've actually got a hybrid environment? Because you're going to end up with two different devices, effectively two different little mini computers, microcomputers, whatever they are, running different stacks out there
Well,
at the edge because you've got a hybrid environment.
yeah. I mean, you could, yeah, potentially you would, but the point is that the point is not that. The point is not whether because we have that problem in the data center. We have Windows servers, we have Linux servers, we have hyper-converged, we have VMware, we have things like Outposts and Anthos and so on. Yeah, so I think it's my point is not that, because that's something, I think that's a different point to talk about, because we'd essentially be taking that problem to the edge as well, right? That kind of hybrid problem to the edge if we end up doing that.
Yeah,
that's not always going to be the case, but that is a potentiality.
Maybe this is something we pick up at a later stage.
Let's do that. That sounds good.
I think you and I could argue about this one for a long time to come.
Indeed. Okay, so I think we'll drop some links to the article in regards to the article in the description of the video. There's a lot more to really say in regards to that, but I think fundamentally our focus for me and Paul is really kind of that edge definition and trying to really cram something, as this kind of NAS solution into an area that maybe it's not really designed for. And then, like I said, my concern with that is, although it may initially tick a box, my concern is kind of scaling and moving forward, and that service requiring more support from that sort of PaaS solution from that platform. I think that's kind of my 2 points of concern. So edges kind of a little bit difficult to define, as you've seen, but also trying to kind of be a jack of all trades, something that will do everything no matter where you run it, on the edge, in the data center, or in a public cloud, I think is not really achievable. And we see that because other systems are geared for those platforms that they're good at, or that they sit on. So would I want to run a kind of a very compacted Kubernetes cluster in a public cloud? I can, but Is that the best thing for my organization? Probably not. I'll probably go for an XKS service in order to, to do that, because that's more convenient, it's easier, and it's, and I don't have to worry about upgrading it and maintaining it and patching it and things like that. Thank you for watching. Please don't forget to subscribe to the channel to support me. You may also want to check out some of the other videos on this channel. Bye for now.